Hey guys, I'm going to finish this problem we set up in class, show you how to do it so you can check your answers. Just as a reminder where the problem came from, it was this problem where we had a particle moving along with the velocity v of t equals -1 plus e to the 1 minus t. So we looked at our equation of that, we found this, we realized, oh, this part's negative, so we really want to break this into two parts, 0 to 1 and 1 onto 3. So we did that here, and so I'm just going to take it from here and integrate these by the separate pieces there. So yeah, we'll use u substitution. We could do them separately. We can also do them together because the u substitution is going to be the same. Maybe I'll just do them the same because we're going to make u be 1 minus t, so that all goes up there in the e. And so if u is equal to 1 minus t, then du is going to be -1 dt. And so if we solve for dt, then we're going to get -1 times du. So when we go to substitute in here, one of the things we do is remember use this for the bounds of integration. And so we're going to plug in the different values in for t, because this is in terms of t, and we'll get something out in terms of u. So let's go ahead and do that. So I'm going to come here, I'm going to plug in 0 in the bottom, and it's really 1 minus 0, right? This thing's popping up in my way, isn't it? So we can get that up there. Then I can't see what I'm doing. Huh. And the other one is going to be 1 minus, I think it was up here, 1. See that 1 up there? 1. And so we get 0 and 1. They just switch places there. That's kind of funny. Let's see, the -1 is still going to be there. E to the u. And then instead of dt, we're going to put -1 du. So be careful that the -1 gets multiplied by everything here. So I might want to throw a parentheses in there so I don't miss that. Come on over here, we then have plus, negative, or just minus. We need to do the same thing for these. So instead of 1, we're going to plug in, well, we had 1 and 3 before. We're going to plug in 1 minus that, right? So we get a 0 in the bottom this time and a -2 in the top. Again, even though these are flipped and the smaller number is in the upper bound, it's kind of weird to say. You can just evaluate it. It works just fine, right? So we get -1 plus e to the u, -1 du. So we actually get the same thing on the inside for both of these, just the bounds that matters. So let us integrate. So with this, we're going to get a -1 u. E to the u is just going to be e to the u, but that -1 is going to make that negative and this thing positive. So we can go ahead and say it's u minus e to the u evaluated from 1 to 0 minus, same thing, we get the exact same thing when we integrate it, u minus e to the u, and this is evaluated, from from 0 to -2. Now, we could take time and change it back into x, but I'm just going to plug it in like it is. Okay, it'll be pretty simple and straightforward. So let's plug in the 0 first. So 0 minus e to the 0 minus 1 minus e to the 1. Okay, all of that. This big minus here. Now let's plug in -2. We get -2 minus e to the -2 minus 0 minus e to the 0. And this is one of those cases where it's important to plug in the 0 because e to the 0 is not 0, e to the 0 is 1. So we evaluate this, what do we get? We get a 0 minus 1, so -1 minus 1 plus e, distribute your negative, plus 2 plus 1 over e squared plus 1. These ones, let's see here, these two add up to -2, and that's +2. So it comes out in the end, it looks like we have, let's kind of write this in a semblance of an order, e plus 1 over e squared is what you would get when you compute all of this. I'm surprised nothing else adds up to 0, but I guess, yeah, those are ones and they don't really eliminate. So yeah, there is our answer to the rest of the free response question. Coming on down here, let's now do this one. You want to think about the u for a second. Go ahead and decide on a u. Now that you decided on a u, I chose 1 over x, partly because it's inside the cosine, but if you think about it, when you take the derivative of this, we're going to get x squared, and that's going to be in the numerator, which is going to divide out with that x squared in the denominator. So that will be actually nice. You can also write this x to the negative first. That will help us when taking the derivative. So du, let's pull the negative 1 out in front. X to the negative 2 dx, right? So when we solve for dx, of course, that's in the denominator. You multiply both sides, you're actually going to get a negative x squared du. You can work it out, and you'll see that will be that back in the numerator. Let's change the bounds of integration. You see, the function is just the reciprocal function, so we can just simply flip that, right? So pi over 2 and pi over 1, which is just pi. We're going to get cosine of u, that's what we wanted, all over x squared. Du, though, becomes negative x squared, sorry, dx becomes negative x squared du. And so these are going to divide out. Be careful not to forget that there is a negative 1 there, right? The negative 1 is left over when you divide that out. So we're going to, let's go ahead and integrate it here. So we get negative cosine. The antiderivative of negative cosine is positive sine. So we get sine of u evaluated from pi to pi over 2. Oops. And so when we do that, sine of pi over 2 minus sine of pi. Let's see here. Sine starts at 0, so sine of pi over 2 is going to be 1. Sine of pi is going to be 0, so 1 minus 0 is 1. And that is what we get for the second one. Sorry guys, I had to come back here because there was one mistake I just noticed. This right here, if you notice, this one right here that I ended up with, we had a negative times a negative times a negative. That should have been a negative instead of a positive. So that changes the answer to this. So it's e minus 1 plus 1 over e squared should have been the answer. Thanks for watching, you guys.